Hey, Dr. Clark coming at you with a Check Your Understanding video. We're looking at section 9.1 on Euler's method. Let's take a look. So the problem in question has us solving an initial value problem with Euler's method. In part A, they gave us the true solution as t plus 1 squared. They want us to verify that. So that just means take the derivative and see if it's equal to twice the square root of the solution. So the derivative of t plus 1 squared is 2 times t plus 1 to the 1. I put question mark equals sign. Is that equal to twice the square root of the solution? Well, the square root of t plus 1 squared is in fact t plus 1. And so we have a match there. For part B, they want us to use Euler's method by hand to find the solution from 0 to 2 with h set to be 0.5. And you can see here, if I work my way through that, my initial condition is the point 0,1, and then the slope at 0,1 is twice the square root of the y-coordinate, which is 1, so that's a slope of 2. And so my new y of 0.5, will be the old y, 1, plus h, 0.5, times the slope 2, and that gives me 2. So now my new point is the point 0.52. Now I'm at the point 0.52. I calculate the slope to be twice the square root of the y-coordinate, which is about 2.8. And my new y will be 2 plus the h times that slope, and I get 3.4142. Then I'm on to the next point. So I'm at the point 1, 3.4. I calculate the slope to be twice the square root of the y-coordinate. I add that, multiply by h, add it to 2, and I get a new y. And the last point will be 2, 5.37, and we can see that by just calculating the slope, adding it to 0.5 times the old y, and getting 5.37. So you can do Euler's method by hand. It's somewhat taxing. And so Excel is a better way to do that. So let me actually kind of jump over to Excel here. What I've done is I've put the h here in D1, and that's going to be 0.05 for question C. I put the t's in A and the y's in B, and I've set 0 and 1 to be the initial conditions. Okay? And then I need to make a set of t's, which the way I do that is I say, okay, take the old t, which is A2, and add it to $D, $1, where I've stored the h. And then if I grab this corner and click and pull down, it will fill down a whole bunch of t's. And you can see each one is A2 plus D1, A3 plus D1, A4 plus D1. So it just adds D1, which is my H value, down the line, which is kind of effective. For the Y values, I want to take the old Y, which I have in B2, and then add the H, which I've got stored in D1. So I go $D, $1, so that's held constant, plus twice the square root of the Y value, which is stored in B2. And then when I fill down here by clicking and pulling down, when I go to the next one, it'll be B3 plus D1 times twice the square root of B3. And then B4 times D1 plus twice the square root. And on down. And if I go all the way down to the point 2, I'm getting 8.8373. That's the y-coordinate at 2. Is Euler's method. So hopefully you got that one right and it's making sense, and we'll see you in the next video.